Hello friends, there is another question from Resnick Halliday's 10th edition. This is page number 140, problem number 9. The question reads, a 3.5 kg block is pushed along a horizontal floor by a force of magnitude 15 Newton at an angle of 40 degrees with the horizontal. The coefficient of kinetic friction between the block and the floor is 0.25. Calculate magnitudes of part A, the frictional force on the block from the floor, and part B, the block's acceleration. So this is the ray diagram, free body diagram that I have drawn. The force F is equal to 15 Newton and it is at an angle of 40 degree. The horizontal component of the force will be F cos 40 and the vertical component will act downward, and that is F sine 40. The weight of the block will also act downward, and that is given by 3.5 G. And the normal force from the surface is given as N. Now, N is equal to 3.5 times 9.8 plus 15 sine 40. Because there is no vertical motion of the block, so these two forces will be equal. Now, the frictional force acting will be in opposite direction of the motion, and that is in towards left, and the friction force Fr is given by mu k n, where n is the perpendicular force which is acting perpendicular to the motion. So mu k is given as 0.25 times n, and we know the value of n from here. So if you calculate, Fr will be 10.98 Newton. So this completes our part A, which has asked the frictional force on the block from the floor, which is 10.98. Now the frictional force acting is 10.98. Now what is the acceleration of the block? So there are two forces acting on it horizontally. One is F cos 40 and the other is frictional force. If we assume acceleration towards right, then we get the equation (15 cos 40 minus 10.98 equal to 3.5a. When you solve this equation, you will get A as 0.145 meter per second square.